Hello students, welcome back to our channel Diksha Karnataka. So as you all know, we have started a series where we are discussing the top 30 questions from all the important chapters. So in this video, I'll be discussing the top 30 questions from the chapter Classification of Elements and Periodicity in Properties. This is a PU1 topic, not a very high weightage topic, but every year we get one question from this. So you have many trends and all in this chapter. So many exceptions are there. So we'll be doing questions that are very important. So let us see the first question from here. The correct order of first ionization enthalpy of the given elements. Okay. So whenever such questions come, first try to place these elements in the period or in the periodic table. Okay. Then you can analyze whether they are from the same group or same period. So we have lithium. Okay. Then if we have four options, right? Lithium, beryllium, boron and carbon. So this is lithium, beryllium, boron and carbon. In the periodic table, they lie in this order. And as we know, along a period, what happens to the first ionization enthalpy? Along the period, the first ionization enthalpy increases, right? So that means if we see, the order should be lithium, beryllium, boron and carbon. This should be the expected order and the answer could have been option number D. But here another factor which influences the ionization enthalpy is your electronic configuration. So if you see lithium, hydrogen, helium, lithium electronic configuration is 1s2, 2s1, right? Hydrogen, helium, lithium 3. Then beryllium is 1s2, 2s2. Then boron is 1s2, 2s2 and 2p1. Okay. Then carbon is 1s2, 2s2, 2p2, right? So this is what is the electronic configuration. Now if you see, for this one, beryllium, it is a completely filled shell, right? From beryllium, the electronic configuration is fully filled. So we will require more energy to remove electrons from beryllium than from boron. Okay. So that is why what happens, the answer here becomes lithium, boron and then beryllium and then carbon. So the correct answer for this question is option number A. So these are some exceptions that you must know. Okay, next question. The property of halogens which is not correctly matched is as. Okay. So this is, we have fluorine, chlorine, bromine and iodine, right? They belong to the same group. Now down the group, what happens? Mass increases, so density will increase. So this is correctly matched. Electron gain enthalpy, if you see, chlorine has more electron gain enthalpy than fluorine. Okay, this is a very important exception. This is because of the small size of fluorine. What is the reason for this? We have small size of fluorine and high electronegativity. Okay. So due to this small size and high electronegativity, there is inter-electron repulsions in fluorine, as a result of which the electron gain enthalpy for fluorine decreases. Rather, chlorine, being a electronegative and bigger size, has a good electron gain enthalpy. So this order is wrong, right? So the correct answer for this question is option number B. Next. The elements X, Y and Z have the atomic number 19, 37 and 55. Which of the following statements is true about them? Okay. So if you see 19, 37 and 55, you can just see 19 plus 18 is 37. Here plus 30 plus 18 is 55, right? So now if you see here, these three elements belong to the same group. Okay. So X, Y and Z belong to the same group. Now, so if you see, Z would have the highest ionization potential. So down the group, the ionization potential decreases. So Z will have least. So this statement is incorrect. Next, Y would have the highest ionization potential. Y is in between, right? So it cannot have the highest. The highest will be for X. So this statement is also incorrect. Next, their ionization potential would increase with the increasing atomic number. So with the increase in atomic number, the ionization potential decreases, right? Down the group, if you see, the atomic number is increasing, but ionization potential will decrease. So this statement is also incorrect. Next, we have Y would have an ionization potential between those of X and Z. Yes, the order is this one, X, Y and then Z. So the correct statement for this question is option number D. Next, amphoteric oxides among the following. So this one you have to remember some examples. Correct answer for this question is option number C. Beryllium oxide is an amphoteric oxide. Okay, next. The third ionization enthalpy is highest in. Okay. So now if you see this alkaline earth metals, right? So let us see the electronic configuration. Alkali metals, the group 1, And for this group 1 electronic configuration is NS1, then we have group 2, that is NS2, right? Now here, for example, take any elements of group 2 elements. For example, we have magnesium. Okay, so what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, right? This one 1s2, that is 10 electrons are there, that is your neon, and 3s2. Now when you remove the third, for the third ionization enthalpy, you have to remove the electron from the noble gas configuration, which is very difficult because it is a stable configuration. That is why for alkaline earth metals, the third ionization enthalpy will be the highest one. So the correct answer for this question is option number B. Okay, next. The first ionization enthalpy of the following elements are in the order. Okay, so now if you see here, again see the elements and arrange them in the periodic table. We have carbon, nitrogen, silicon and phosphorus. So carbon, after that nitrogen, below carbon there is silicon, below nitrogen there is phosphorus, right? Now if you remember, this is group, these are down the group and this is along the period. Now down the group, what will happen? This ionization enthalpy will decrease. So I can definitely say phosphorus and silicon will have less than carbon and nitrogen. Now along the period, what happens? It increases. So phosphorus will have more than silicon, right? So that means the lowest will be silicon and then phosphorus, right? Now if you see here, again along the period it will increase. So next will be carbon and then next will be nitrogen. So the correct answer for this question is option number D. Okay, next question. Which of the following is the correct order of radius? So this is very simple question. Always remember that if there is negative ion, then neutral, okay, and then cation. Negative ion, neutral and then cation. In this negative ion, of suppose 2 or 3 negative ions are there, higher the charge, okay, higher the charge, more is the size. Okay, this is for negative ion. For cations, what you can say? Higher the charge, smaller is the ion. Okay, so now if you see, we have this negative, neutral, positive. This can be the answer. Now if you see here, negative is smaller and cation is, so this is incorrect. Here also you see these two negative ions are greater, but 2 minus should be greater than F minus, so this is also incorrect. Here you can see negative ion is at the end, that is incorrect. So the correct answer for this question is option number A. Next, which of the following, again amphoteric, can remember some examples. Aluminium is an amphoteric oxide. Correct answer is option number B. Next, the electronegative of carbon, nitrogen, silicon and phosphorus are in the order of, okay. So now again we will check them. Carbon, silicon, nitrogen and phosphorus, right? Now we know down the group electronegativity decreases along the period. So down the group what happens? Electronegativity decreases and along the period electronegativity increases. So definitely silicon and phosphorus will have less than carbon and nitrogen. But if you compare out of these two, phosphorus will be having more, will be more electronegative than silicon. So silicon will be least, then phosphorus, right? Out of these two, carbon is least, then nitrogen. So the correct answer for this question is option number A. Okay, next. For one of the elements, the various successive ionization enthalpies are given below. The element is, okay. So now if you see here, how to find this type of questions, you have to see the values. Whenever there is a sudden rise, okay, that point you have to check. So if you see here, here it is 577, 1800, 2700. Here you can check from 2752 the value increased to 11,580, right? So that was a, like, that means you can know after removing 3 electrons there is a stable electronic configuration is there after removing 3 electrons. So that is why there is a jump in the electronic configuration, jump in the ionization enthalpy for the 4th electron. Now if you see these elements, okay, so phosphorus, aluminum, magnesium, silicon and aluminium. So if you see aluminium electronic atomic number is 13, right? So it is neon, right? So I can write like this: 1s2, 2s2, 2p6, 3s2 and 3p1, right? 6, 7, 8, 9, 10, 11, 12, 13. This part is your neon electronic configuration. Now after removing these 3 electrons, 2 plus 1, after removing all the 3 electrons, you can see the next 4th electron has to be removed from the noble gas configuration. So that is why this electronic or this atom or element is nothing but your aluminium. Okay, so the correct answer for this question is option number D. Okay, now if you see for silicon, silicon is 14. So we have 1s2, 2s2, 2p6, 3s2 and 3p2, right? So 10, 11, 12, 13, 14. Here the 4th electron is not disturbing the noble gas configuration. Similarly, you check for magnesium and phosphorus also. So correct answer is option number D. Next, the correct arrangement of the ions in the increasing order of their radii. So again the same thing, positive and negative. Increasing order means lowest to highest. Okay. So cations will come first and then anions will come. In the cations, higher charger cations will come first, and then anions, higher charger anions will come at the last. So now if you see here, we have calcium 2 plus. So elements that are given are calcium 2 plus, chlorine minus and Na plus, right? So in this, cations are Ca2 plus and Na plus, and the highest charge is for Ca2 plus. So first will be Ca2 plus, then K plus, and then S2 minus. Okay, so the correct answer for this question will be option number B. Here you can say negative ion is coming in between, so that is why it is incorrect. Here you can see the charge, it should be first plus 3, then plus 2 and then plus 1, so this is also incorrect. And here it should be Cl minus, F minus, along down the group the size increases. Okay, next, for the properties mentioned, the correct order of the trend for the different species is in. Okay, so we have to tell in which of the following the trend given is correctly matched. Lewis acid strength, so we have BCl3, AlCl3 and GaCl3. So Lewis acid character means the tendency to accept electrons. Okay, so tendency to accept electrons depends on the electronegativity. Or now, since boron is smallest in size and highest electronegativity, it can accept the electrons more easily as compared to these two. So that is why the strength as the Lewis acid, this statement is correct. Now if you see this one, inert pair effect increases when there is, like, it increases down the group. Okay, so this one is incorrect here. Now oxidizing power again depends on the oxidizing means oxidize others and reduce itself, and reduce itself is gain of electrons. But here what happens, due to the inert pair effect, the trend changes. Okay, now same here, in the first ionization enthalpy, this order is not correct because this one has again inert pair effect here, due to which the first ionization enthalpy value changes. Okay, so the correct answer for this question is option number A. Next, which of the following ions is smallest in size? So we can see negative ions we will not consider, positive ions will consider. Again in positive, the one which is having higher charge. So the correct answer for this question is option number C. Next, which of the following has a positive electron affinity? So positive electron affinity means when you add the, electron affinity, we have positive electron affinity means it doesn't want to add any electrons to itself. So which elements will not require any electrons in them? Those were already stable. So generally noble gases, okay, noble gases show positive electron affinity. So the correct answer for this question is option number C. Next, the decreasing order of the ionization potential of the following elements. Okay, so now again let us note down all the elements in the periodic table. So we have neon, that is the last element, then we have chlorine here, and then we have phosphorus, we have sulfur. Okay, next we have magnesium and aluminium, right? Okay, so now if you see here, in this we have to arrange them in the ionization potential. Along the period, what happens, the ionization potential increases, right? So now if you see, so this is your beryllium, boron, then we have nitrogen, here it is oxygen, and then it is fluorine, right? These are the elements present here, and the next one. Now if you check properly, you have to check here. So neon is a noble gas configuration, so it will have the highest ionization enthalpy because of the stable electronic configuration. So that is why we can see all the options are having neon first. Okay, now if you see along the period, chlorine comes the next, so it will have the next, so that is why chlorine is present. Now here there is a challenge between sulfur and phosphorus. Now if you remember, group 15 elements have a, what is the speciality of group 15 elements? They have a half-filled stable configuration. So please remember this one, very important, half-filled stable electronic configuration, as a result of which this one, phosphorus, will have more than sulfur. If we consider along the group, all sulfur should have more than the phosphorus. The expected result should be this one. Okay, this is the one which is expected, because along the period the ionization enthalpy increases. But here there is a small thing, that phosphorus has a stable electronic configuration, so that is why this one changes here. So we will get neon, chlorine, phosphorus will come, and then sulfur will come, right? So then we can eliminate these two options. We have phosphorus and sulfur, phosphorus and sulfur. Now if you see in magnesium and aluminium, right? So again, what is the, okay, if we see now magnesium and aluminium, magnesium electronic configuration is 1s2, 2s2, 2p6 and 3s2. If you see for aluminium, it is 1s2, 2s2, 2p6, 3s2 and 3p1, right? Now you see, to remove the first electron, from magnesium we have to remove the electron from a fully filled orbital, which is very stable, but that doesn't happen in case of aluminium. So again here also what happens, magnesium comes front and aluminium goes down. So the correct answer for this question is option number B. Very important question. Okay, two logics we have to use. First is the most important thing which affects the ionization potential is your electronic configuration. Okay, all the trends along the period increases, decreases, but the first thing that we have to consider is electronic configuration. So there are two cases here. First is phosphorus and sulfur. Phosphorus has an exactly half-filled electronic configuration, so it will have more than sulfur. And next one is among aluminium and magnesium. Magnesium is having fully filled, aluminium is not having a fully filled cell. So that is why there is a change in that option also. Next question. Which of the following is the correct order of ionization potential for boron, carbon and nitrogen? Okay, so these are in the same period, boron, carbon and nitrogen. So as we know, along the period what happens, the potential, ionization potential increases. So nitrogen will be maximum, then carbon and then boron. So the correct answer for this question is option number B. So this is one easy question. No exceptions are used here. Next, the order of the first ionization enthalpy of lithium, beryllium, boron and sodium. Okay, so this is how we have to write in the periodic table. First mention, position the elements so that you can know where they are lying. Then only you can you can apply the trends to the elements. Now as we know, first this one we have to arrange in the, okay, this is given in the decreasing order. So sodium is in the another group, down the group it decreases. So sodium will be last. So we can eliminate this option. Now if you see these three, along the period it should increase. So we should have boron, beryllium, lithium and then sodium, right? So we can see this option is not there. That is good that this option is not there. But now if you check here, beryllium, again electronic configuration is 1s2, 2s1, sorry, 1s2, 2s2, 2p1. This is the electronic configuration of boron, and beryllium is 1s2 and 2s2. So this is having a fully filled orbital, so that is why the electron ionization enthalpy increases for beryllium, and there is a shift here. This one comes here and this one comes here. So the correct answer for this question is beryllium, boron, lithium and then nitrogen. Correct answer is option number B. This is also important question. All questions you should know. For beryllium and boron there will be exceptions. For group 15 elements there is an exception always. Okay. Next, which of the following are isoelectronic species? Okay, we can calculate here. So carbon, first compound, carbon is having 6 electrons, 6 plus 3 9, then 1 is removed, so total 8 electrons are there. Now if you see second one, okay, nitrogen is having 7 plus 2 here 9 and plus 1 electron, so that is 10 electrons. So wherever 1 and 2 are there, those options we can eliminate. Okay. Now if we see third compound, that is NH4 plus, so we have here 7 plus 4 and subtract 1 electron, so that is again 10. Now if you see the fourth compound, we have 7 plus 3, that is again 10. So all these three species, 2, 3 and 4 are having the same number of electrons. So the correct answer will be option number B. Next, the screening effect of inner electrons of the nucleus causes. So what is the screening effect? So due to screening effect, what happens? The outer electrons, okay, the outer electrons are shielded by the force, by the effective nuclear force. So as a result of which the nuclear force do not reach to the last electron, and the ionization, they can be easily removed from the atom. So that is why there will be a decrease in the ionization enthalpy. So the correct answer is option number A. But if the question here could have been the screening effect of inner electrons mentioned as D and F, okay. So as we know, D and F have very poor shielding effect, and due to which the effective nuclear charge increases. So in that case, what happens? The ionization enthalpy increases. Next question. The oxide of which of the following will be acidic in character? So we know the oxides of non-metals are generally acidic. So here the non-metal is chlorine. Correct answer is option number D. And non-metal is acidic. Here you can remember metal oxides are basic. Okay. So this is also important point. Next question. Ca2 plus is isoelectronic with. Okay, so Ca2 plus calcium is having 20 electrons. Then Ca2 plus will have 18 electrons. Argon also has 18 electrons. So the correct answer for this question is option number C. Next, which of the following isoelectronic ions has the lowest ionization energy? So again, when we calculate here lowest ionization energy, okay, so first of all, you can calculate all of their K plus. We have Ca2 plus and Cl minus and S2 minus, right? So if the number of electrons are more, the ionization enthalpy will decrease. If the charge is positive is more, that is means the electrons are held more tightly here. Electrons are held tightly here when the positive charge is more, and if negative charge is more, electrons are held loosely. Right? So if it is held loosely, it can be easily removed and the ionization potential decreases. So the correct answer for this question is option number D. Next, the correct order of increasing metal character is. So we have beryllium, magnesium, calcium and barium. So down the group, metallic character increases. So the correct answer for this question will be option number A. Okay. So metallic character for metals increases down the group. The next question, the ionization potential is lowest for the. Okay. So if you remember, alkali metals has a general electronic configuration of NS1. So it is half filled. So we can easily remove electrons from this one. So the correct answer for this question is option number D. Alkaline earth metals has NS2. Okay. So they are having completely filled valence shell. So it will be taking, we require more energy to remove electrons from here. Inert gas, they are having stable electronic configuration. So it is also difficult. Okay. And halogens has NS2, NP5. Okay. So next question. An element X has the atomic number of 34. Its position in the periodic table is. Okay, so 34 means the electronic configuration is 4s2, 3d10. So up to this, it is 30 electrons, and then we have 4p4. Okay, so if you see the highest value of n, okay, the highest value of n is 4. So it is fourth period. So we can eliminate these two options. Now group is, we have to calculate the number of electrons in the NH shell. Number of electrons in NH shell. So we have here 4p electrons and 4s electrons. So total 6 electrons are there. So group 16. So the correct answer for this question is option number C. Next. The energy of the electron in the ground state of the hydrogen is given this much. That is 2.18 into 10 to the power of minus 21 kilojoule per mole. Okay. means this is the value of 1 mole of electrons bound to the hydrogen atom. Now the ionization enthalpy of atomic hydrogen in kilojoule per mole. So for per atom, if you want to calculate, we have to just take it minus 2.18 into 10 to the power of minus 2 into 6.022 into 10 to the power of 23. Now see, this we have to provide this much energy to remove the electron, so the value will come in the positive, and if you solve this, we'll get 1313. So the correct answer for this question is option number B. Okay, next question. Which of the following has more negative electron gain enthalpy? So this is very important question. We have the oxygen, sulfur, fluorine and chlorine. So first of all, along the period, the electron gain enthalpy will increase. So fluorine and chlorine will have more, but again due to the small size of fluorine, there is electron repulsion. So chlorine has the highest electron gain enthalpy. So the correct answer for this question is option number D. Next, the increasing order of metallic character among the following elements: boron, aluminium, magnesium and calcium. So if we place them in the periodic table, we have lithium, here sodium, potassium, and here we have beryllium, magnesium, and then boron and aluminium, right? So increasing order of the metallic character. So along the period, metallic character decreases. So potassium will have the maximum metallic character. So first we can eliminate these two options. Then along the period also metallic character decreases. So we have boron, aluminium and then magnesium, right? So if we compare after this, magnesium will have the next one. So that is magnesium. And out of boron and aluminium, down the group metallic character increases. So aluminium will have more than boron. So aluminium and then boron. So correct answer is option number A. Next, the ionic radii for Fe, Fe2 plus and Fe3 plus. This question is very simple. As the charge increases, for the cation, size will decrease. So Fe will be the biggest one, then Fe2 plus and then Fe3 plus. Okay. So correct answer for this question is option number D. The last question. Na plus and Ne both are isoelectronic with 2s2, 2p6 outer electronic configuration. Their ionization enthalpy values are related as. Okay, so this is very important one. If we compare a charged species, positively charged species, okay, and a neutral atom, okay, so the positively charged species will have more ionization enthalpy than the neutral atom, okay. So this is because here, due to the positively charged, the electrons are held more tightly, so that is why the ionization enthalpy will increase. So this is not equal. Ionization enthalpy of Na plus will be greater than ionization enthalpy of neon. So the correct answer for this question is option number B. Okay, one more question is there. To which period and group the element with the outer electronic configuration of Ns2 Np3 belongs, where N is equal to 3. So we have here 3s2 and 3p3. So the highest N value is 3. So it will belong to period 3. So we can eliminate these options. And now if you see, total number of valence electrons is 5 electrons. So we have to add 10 here. So group will be 15. So the correct answer for this question will be option number D. Okay. And so these were the top 30 questions from the chapter Classification of Elements and Periodicity and Properties. So just focus on the trends, all the exceptions from this chapter. This is very scoring topic. So if you have found this video useful, please like, share and subscribe the channel. Thank you.